All right, well, hey, welcome to Mat104 Trigonometry here at Lake Tahoe Community College. My name is Bruce Armbrust. I'm one of the full-time math faculty here at the college, and I will be your guide, let's say, through trigonometry. I'm just going to get this out on record. This is my favorite class. I love this class. I love everything about it. I'm super excited about it. And hopefully that passion and enthusiasm rubs off a little bit. But I love this class, so I'm super thrilled to be in here with you guys. What I want to do before we dive into trig is I want to talk a little bit about just how this class is going to go. We'll talk a little bit about what to expect in terms of homeworks and all that, go over the syllabus and that kind of stuff. So first, let's just get this out of the way. So this Zoom world is weird. I'm sure some of you have been doing it for a while. This is now, what, a year plus for a lot of us. So you're probably pretty comfortable with it, but I'll just tell you sort of my expectations and things that I like. In terms of microphones, if you would do me the favor and stay muted unless you're asking a question or making comment or something like that, that would be awesome. Helps keep background noise down. Also, I record these videos and I put them up on YouTube. And the way that Zoom works is it will record whoever is speaking. So if you just happen to have your mic on and it's making some background noise, it will flash over to your screen, kind of take it away from whatever I'm trying to present. So just makes it so it's a little bit harder for folks to see later. So just do me a favor, keep it muted, that'd be awesome. In terms of cameras, I don't require you to have your cameras on. I don't. I would prefer that they're on. I like to be able to see people. Otherwise, I'm just talking to a screen of names, which I'll still do. It's a little bit more boring, and I'm probably not as effective if I don't actually see folks on the other side. So, but it's totally up to you. If you don't want to put your camera on, you don't have to put your camera on, right? Anyway, so that's just a little bit about the Zoom. I'll start every day with just a little bit of time where we can discuss things off the record before I hit record, but plan on that to be kind of the common thing. All right, so those are just some of the Zoom ideas. Let me go over the syllabus so we can kind of talk about what to expect and what you're going to need to do. So I'm going to go ahead and share my screen and show you guys my syllabus here. I actually lied. There we go. All right, so here's the syllabus with just a few things that I don't want out on YouTube. So you have access to this on the Canvas. When you go onto the Canvas site, this file is already there, but let me just go ahead and talk about it. So right now, really the way that you can get a hold of me is by email, right? So you have my email address. You can also message me through Canvas. I'm usually pretty good about responding, with the exception of, say, weekends and things like that, because I also have a life that's outside of trade class. So, but I will do my best to respond to you within 24 hours. Also realize that you may not get an instantaneous response because there are hours of the day where I cannot email, right? Like when I'm doing this, when I'm with you guys, if I get a question from one of my other students, it's just sitting in my inbox until I'm at a point where I can answer it, right? So realize the same thing's going to happen for you. I do teach other classes, and trig is not my only class. I know for you guys, it's probably your only math class. Well, I also teach differential equations. I'm also teaching modern physics, right? So I've got a lot of other stuff going on. So just realize it's not going to be right away. That's not a problem. That doesn't mean I'm ignoring you. It just means I haven't had a chance to get to it. All right, but I will respond to you within 24 hours, again, with the exception of weekends and holidays. So we're going to be doing everything in this, what we call EVE format, Enhanced Virtual Education. And basically, it just means we're going to be in here on Zoom, running this class as if it were a regular face-to-face class at the same times every Monday and Wednesday. So we're going to be in here. It's not the same, right? It's not the same as being in the same room together. but it's not terrible. And it seems like the more I do it, the better we all get at it. But I do record all of my lectures and put them up on YouTube. To find it, just search my name, look for Bruce Armbrust LTCC lecture series. You'll find them. And I have them all split up by courses that I've taught. Now, you do have to understand, if you go and you look there now, there are a bunch of classes from Mat104, and those are from last spring. So if you want, I mean, you can already get a preview of things that are coming from the previous classes, but there'll be another set from ours. But I always date them, so you know exactly which one it is. So like today's will say Mat104, April 5th, 2021. So you'll know exactly which one is yours. Okay, so that's when we're going to do class. Now, I'm also available outside of class if you want to talk to me about other things, right? So I call these student hours. A lot of people call them office hours, the same thing. But I like calling them student hours because these are hours for you guys, the students, to come and chat with me. So these are times that you can find me outside of class that I'm willing to talk to you about, well, really anything. We can talk about course material that's an issue for you. We can talk about other stuff, like maybe you're having trouble with your technology and accessing class, or you want to know what classes you need to take for certain majors and whatnot. I'm happy to talk to you guys about pretty much anything. And so I do those via Zoom as well. It is a different link, but you can find that on the syllabus. You can also find it in the Canvas shell. I'll show you where you can find that in the Canvas shell. But the times that you can find me in that Zoom room are right here. So you'll see that I've got hours on Monday, Tuesday, Wednesday, and Thursday. I don't have any on Friday for a couple of reasons. One, most students don't try to find me on Friday. And also Friday, I'm kind of busy with other meetings and whatnot. So, but you can pop into that room. You're going to be placed into a waiting room. If nobody's in there with me, I'll just bump you right in. If I'm with someone, you might have to wait a little while. But again, just realize I'm not ignoring you. It's just I'm working with another student at the time. All right, so those are times you can definitely find me. But I also know that you guys also have other classes, other work, other schedules. If these times don't work, and you go, man, I'd really, like to find another time, send me a message, send me an email, and I'm more than happy to try to work around our schedules so that we can find a time that works for both of us to get together. Okay. So don't look at this and just go, well, crap, I can't make any of those times, so I'm not going to bother trying to talk to him. Please don't do that. Please don't do that. I'm like legit. I'm very happy to find time. We just have to dance around the schedules. Okay. All right, so the textbook that we're using, it's called Algebra and Trigonometry, and it is an open source textbook, meaning it's going to cost you $0. You can access it online. I've got the link here on the syllabus. There's also a link in the Canvas shell. So you can actually access it online for no dollars. If you came through our sequence and took Math 103A or Math 103B, it's the same book. We're just going to be doing different chapters. You actually also can buy a physical book. I've got a copy. It looks like this. I think they're actually really cheap if you want to buy them, but you don't have to, right? If you don't want a physical book. I'm super old school. I hate reading on the computer. So I like actually having the text in hand. Like Kindles just don't work for me. My wife loves it. Hate it. I hate it. So I'm a physical book kind of guy. But the point is, you can actually get this for free. All right. So that's the text we're going to be using, and everything's kind of built off of that. So the course description here, this is basically just what trig is. If you look at it, it probably doesn't mean a lot to you right now, unless you have a little bit of background with trig. But by the time we are done with this class, so come June, you're going to look at all those things and go, oh, I know what that means. All right. So basically, we're going to look at trigonometry, whatever the hell that means. And these are all basically the big pieces of trigonometry. The other thing I'm just going to mention real quick is this is part of the pre-calculus sequence. And I just want you to think about that word for a second, pre-calculus. A lot of what we do here is to help you in calculus. I'm also one of the calc teachers. When you go and you take calculus, if you take it at the college, at Lake Tahoe Community College, you will see me for some of the calculus classes, not all of them, because there's another guy, Larry Green, who teaches them as well. But because I teach calculus, I know where the trig matters and where it comes important. So I'm going to tell you off and on, and I'll tell you something like, okay, hey, pay attention to this. This is going to be super important in calculus. Try to put that into your brain and go, okay, this is something I should definitely remember. Because then when we get to calculus, I go, hey, you remember back in trig when I said this is something we're going to run into them again. So trig is actually a really important tool to help you do calculus. So just be aware that sometimes you may wonder what I'm doing. There is method to my madness because I'm trying to prepare you for calculus. All right. So other stuff, prerequisite, co-requisites. You should have started the calculus or the pre-calc sequence. If you haven't, this class is going to be a lot more difficult. Calculators. I strongly recommend having a calculator. Now, because of the Eve world, you can replace graphing calculator with graphing feature on whatever form of technology you have. There are a lot of really good resources online to help you with this sort of thing. For example, Desmos is my favorite online graphing. Wolfram Alpha is probably my favorite computational place on the internet, right? But there are all kinds of these things, and you can do Google searches to find a lot of the information. But it's still probably handy to have a good graphing calculator. I'm a big fan of the TI-89, which is what we call a CAS, a computer algebra system. But you don't have to use TI-89. You don't even have to have a calculator. But there are going to be times where drawing the graph is super useful. And there are going to be times when you need to actually do the numerical calculations. If you are using some sort of an actual physical calculator, make sure it's at least scientific. It's got to know all the different trig functions, sine, cosine, tangent, and so on. All right. So student learning outcomes, this is what you're going to be able to do by the end of the class. But let's talk about course grade, because that's what you actually care about. In my experience, that's the only thing students actually care about, is I want to get the A. So how's your grade going to break down? Well, I'm, again, old school, the 90, 80, 70, 60 kind of scale. And your score, overall grade, is going to be formed by your performance on these different assessment instruments. So we've got homework, quizzes, 3 regular exams, and a final exam. Okay, so first of all, notice these dates. The dates for the exams, you can pretty much just go ahead and put those in your calendar. Those are going to be the days we do the exams. What they cover might change a little bit depending on if we go faster or slower, but plan on those. So basically, there's a test about every 3 or 4 weeks. Okay, so just nice and regular. But anyway, so those are our dates. You can always see what your grade is on Canvas. The grade book, it stays current as soon as things get graded, it gets in there. So you should always know roughly how you're doing as we move along. So homework. Homework, you're going to be doing that through Canvas. All right, it's through this program called MyOpenMath. Again, if you come through our pre-calc sequence, you've seen this. If you haven't, and you've done stuff with like Pearson, MyMathLab, and things like that, it's very similar. I'll show you here in just a second. But every homework or every section is going to have a homework assignment. In fact, there might be a couple per section depending upon which sections they are. But homeworks are due Monday night at midnight. Technically 11:59. I don't go at 12 a.m. because then people get confused, because like Monday 12 a.m. is actually midnight Sunday night, and so I just go 11:59 p.m. so that we don't get confused there. But they're due Monday night. So you've got basically a week to finish the weekly assignments. I don't recommend that you wait until that last minute because you know that inevitably that's going to be the time that the internet goes down, that your computer starts just like doing one of those update dumps that takes half an hour or whatever. So don't push it. Also, because I give you an entire week, I'm not really sympathetic, honestly, when I get those emails of I tried to get on at 11 o'clock and it's not working, and in my mind I'm like, right, you shouldn't have waited till 11 o'clock. So I'm not super sympathetic there, but please let me know if there are issues. It's not that I'm a monster, it's just uh, it just gets old when it happens all the time. And so don't push it. You got plenty of time. And the other nice thing is you can keep trying your homework. So you get it wrong, you can try it again. The way I've got it set up, you can repeat attempts on the homework. So anyway, other things that are kind of important. Oh, the only Monday that's not going to be a due date is on Memorial Day, because if we've got don't have class that day, I'm not going to make that due date. So at the end of May, that's the only one where there's not a Monday night homework time. But I want to draw your attention here to the last line, because this is kind of a biggie. If you do all the homework assignments, right, and you get a score of at least 50% on each one of them, so not an overall score of 50%, but every single homework assignment has a score of at least 50%, I will drop your lowest regular exam score. Okay, so think about what that means. Now that means when you get to the exams, the pressure's off the exams. The pressure's off one of the exams, right? If you bomb an exam, no big deal. As long as you've been doing the homework, I'm going to throw that score away as if it never happened, right? You bomb 2 exams, now we're going to have to worry about it. But this at least takes the pressure off of one of the exams, all right? So basically, do your homework. If you get at least 50% on each one, then I will drop your lowest exam score. But this is like that horrible like math teacher trick, right? This makes you do your homework. And when you do your homework, you tend to do better on exams. So drop an exam doesn't really matter as much. Yeah, but it matters, right? Who are we kidding? All right, so that's the homework. So quizzes, I've got scheduled right now 6 quizzes for the quarter. And basically these are going to be happening on weeks when we don't have exams. The idea behind the quizzes is just to make sure everything is fresh, that you're kind of keeping up with stuff. So they're going to be very similar to homework problems, just a couple of questions, just to kind of make sure, like I'm saying, like I said, that you're on track. And I drop your lowest quiz score, period, for everybody. No tie into homework or anything. All right. So no matter what, if you get a bad quiz score, it's gone. So I do drop your lowest quiz scores, but because I do that, I don't let you make up quizzes. I am happy to adjust things ahead of time. Like if you're looking at your life schedule and you go, oh man, something funky is coming up. I'm willing to adjust. All right. But if you just later go, oh man, I completely forgot there was a quiz and I didn't get in there and I didn't do it. Well, that'll be the one that gets dropped. Okay. So, but again, it takes a little pressure off the quizzes, makes them pretty low stakes, which they should be. That's just really just to kind of make sure that you're keeping up with things. So the way that we're going to do quizzes is they're going to actually happen at the start of class. So our class starts at 11 o'clock normally, right? So on the day where there is a quiz, it will be available on Canvas starting at 11 o'clock in the morning, right? So whatever the date is, let's just throw out a date. Let's say that we'll go with April 14th. I don't know that there's a quiz that day, but I think there is. So let's say on April 14th, there's a quiz at 11 a.m. You can go in there into the assignment section of Canvas. I'll show you where that is too in just a second. Click on it. It'll pull up a PDF of the quiz and you can start the quiz. All right, now you can do this. I've had students do it where they type onto it, where they print it out and write on it. I've had it where people just write out on a separate piece of paper. I don't really care how you do that. But you do need to then upload it through Canvas in the assignment, because on the assignment it'll has a little button where you upload. You need to upload that file into Canvas by 11:40. Now, it might feel like a weird timing there, 11:40. Here's basically my mindset. In class, if we are doing a quiz, I'd give you probably 30 minutes. I give you an extra 10 minutes to deal with technological issues. All right, so again, this isn't you've got 40 minutes to take it. It's you've got 40 minutes to take it and get it uploaded. So plan on 30 minutes to do it, and then the extra time to make sure that you get it uploaded. I do prefer PDF format. It makes it much easier for me to access things and grade them and manipulate them so I can read them and whatnot. If you're like, how do I do that? There are a lot of apps that will make things into PDFs. I use one, it's called Cam Scanner. It's definitely not the only one out there. I think I don't have an Apple, so I don't know about iPhones, but I think iPhones may even have their own internal kind of thing where it can convert it into, so where you take a picture and then it turns it into a PDF. But I prefer PDFs. If that's too big of a hassle, that's okay. I'll still take photos, JPEGs and stuff like that. Just make sure that you get them uploaded and make sure that they're legible. That's the other issue, especially with photographs. Sometimes when people take a picture, it doesn't focus or something like that, or part of it gets cut off and I can't read it. It's in your best interest to make it that it's legible to this guy so that I can actually give you the appropriate grade. Okay, so anyway, so for quizzes, start them at 11. You just got to get them uploaded by 11:40. Now, all those timing things are on Canvas as well. So it's not like you have to try to remember this. It will clearly show you. All right, so there'll be 6 quizzes. And then there are the 3 exams. And exams are kind of the same deal. I do realize that these are take-home, open book. I do not use Proctorio. I know some of you have probably taken classes where you have testing done by Proctorio, where like you got to make sure only certain things are open on your screen, and you got to have eye contact, no motion in the background, blah, blah. Okay, I find that to be just way more hassle than it's worth. So I don't do that. Okay, but realize I understand that that means you have access to other things that Proctorio would catch. So expect my exams to be difficult. I'm going to put it out there. They're going to be challenging because I have to design them in such a way to make sure that you're not using things that basically do it for you, right? I know about Symbolab. I know about Chegg. I know about all these things, right? I'm not dumb. I know about all this stuff. So I design things so that if you use things like Symbolab and Chegg and whatnot, that I can tell. All right, so I can definitely tell, please don't do that. Show me what you know. That's the whole point of this, is for you to learn how to do this. Show me what you know. If all it's about for you is getting an A, well, that's all it's going to be about, but that's not going to help you when it comes time for calculus. And I'm also going to tell you that eventually the world will come back to face, and you're not going to have those resources. And that's going to be a very rude awakening when it's in the middle of a calculus exam and you go, I don't have my whatever online resource you're used to. All right. Anyway, so just realize that I know this as well, that exams, that you have these resources, but they're going to be take home, open book. Like I know this. And it's going to work kind of the same way. It's going to start at 11 o'clock. They're going to open up, but you're going to have until 1:30 to turn them in. So that's 2.5 hours. Again, it's kind of the same mindset of I'm giving you the 2-hour test chunk and then the extra 30 minutes to deal with technological issues. All right, so, but the same deal here. I prefer that they get uploaded as PDFs, but in a pinch, they can be anything. And also just realize that sometimes there are issues with uploading. If that happens, send me an email, send me a message, attach your files. All right. And as long as they're relatively close to the time, I'll probably be good with accepting it. If you send me an email, let's say at like 5 o'clock that night and go, oh, here's my exam, that's not going to make me very happy. Right. So try to get it done and uploaded, please. All right. So those are the exams. And then the final exam, which what day was that on? June 21st. I believe that's the Monday of finals week. So our class is going to be done on the Monday. It will be a cumulative final, meaning it covers everything for the quarter. But trig really builds on itself. So stuff that we're talking about today, you're still going to do in June. All right, trig is that way. All right, so that's how your grade's going to break down. It's pretty standard, but of course, if you have any questions, please let me know. Just some other stuff on the syllabus for you. I've got the registration info there just so that for your reference. Those are like the drop dates and things like that. How to succeed in a math class. By this point, you're probably figuring it out, but I give students these 5 recommendations. First, come to class. Just come to all the classes. When you don't come to class, it's a lot harder to pick things up. I mean, obviously, if people could just pick up a math book, read it, and understand it, I wouldn't have my job, right? So, and sometimes I actually have decent information to give you. I don't teach you directly from the book. I use the book as the guideline of what topics I need to teach, but I don't like read to you from the book. I make up my own examples. I have my own spin on things. So anyway, so come to class. Do the homework. This is another one that seems kind of obvious, but a lot of people will kind of forget to do, or they'll just like rush through the homework. Homework is where you practice. And math is just like anything else. You can't just watch me do it. You got to do it yourself, right? Like I'm a big baseball fan. Love watching the game. And you know, like you might watch a game and go, oh man, Mike Trout, he makes hitting home runs look easy. Well, I'll tell you what, you get into that box and watch a 90-mile-an-hour fastball go by, you won't even touch it because you don't practice, right? So do the homework. That's where you practice. Number 3, read the book. That one's really hard to do because math books are boring, but again, they're coming at it from a slightly different perspective than me. And so sometimes you might get some nice little nuggets there. Number 4, make use of tutors and my student hours. We do have math tutors available to you through the library. You can find them. I gave you the link here. It's called Cranium Cafe. You can also find it through the college website and all that. But there are math tutors, and a lot of them have taken trig. A lot of them have taken trig from me. So they'll know me, they'll know my expectations, but they can definitely help you. But also don't hesitate to come and ask me, right, if you're having issues. You should know I will never judge you on having trouble with certain math concepts. I'm not that guy, right? Really, I'm only going to judge you on your choice of baseball team to cheer on, really. No, and even that, just joking. I'm not going to judge you. And I truly, like, the reason I have this job is I want to help you understand it and see its usefulness and see its beauty and see its connection to other things. So if you're struggling, please let me know. There's nothing worse than that drowning feeling. You know what I'm talking about? Like in a class where you start not understanding and you struggle a bit and you're like, okay, I'm going to get it, but you don't. And then it moves on. And then you're like, oh man, now I don't understand this. And I don't understand the next thing. And and I liken it to drowning, right? Like you can't just, the surface keeps going further and further away from you. And that's a horrible feeling, horrible feeling. If you start feeling like that, come to my office hours, because then I can go in and grab your hand and pull you up. All right. So anyway, get help if you need it. And then the last one, do a little bit of math every day. Worst thing you could do is on Wednesday when we're done with class, just sort of like check out from math and not thinking about it again until Monday morning when you come back to class, because your brain is going to have forgotten most of it. Our brains are really, really good at remembering stuff, but only if it's what our brain thinks is important. if you're not thinking about it, your brain's going to go, that's not really important information, and it's going to go away. All right. So anyway, do those 5 things. I promise you will make it through this class. Students with disabilities, if you work through the DRC, please let me know. Also contact them and let them know that you're in my class so that I can give you reasonable accommodations. Library and learning services, some good news that's kind of new since I wrote this. The college is starting to open up a little bit. And in fact, the library, you can actually now make appointments to have time in the study rooms in the library and things like that. So stuff is starting to open up. For sure, check out Cranium Cafe, find out what's going on in terms of what the library and learning services can do for you. But there are all kinds of great resources there. Like I mentioned here, the tutors, but also research help. They've got Chromebooks you can borrow, all that good stuff. So as far as I know, this is up-to-date information. As far as I know, if things change, if I get any emails regarding how they've changed what's going on, I'll be sure to pass it on. All right, and then academic dishonesty, I kind of already talked about that. Show me your work. Don't show me the work of Simba Lab, right? Show me your work. Anyway, all right, so course schedule. This is very tentative. Every time I teach trig, things are different depending on the group. But basically, we're just going to do chapters 7 through 10 in this book. Chapter 7, I'm going to introduce you to the tools of trig. There are functions, the trigonometric functions. Chapter 8, we're going to look more in depth at those functions in terms of like what they look like, their properties. Chapter 9, I'm going to show you what are called identities. These are relationships between all these functions. And then chapter 10, we're going to start applying it. All right, so it's kind of that standard way we do anything in math. We introduce it to you, talk about all their properties, and then we use them. Well, that's the same thing that's going to happen here in trig. All right, it's going to follow that exact same path. So I do have the dates of all the quizzes and exams on there, including the final exam. The final is a slightly different time because we got a weird final exam schedule. I'll remind everybody about that when we get there. But it actually starts at 10 instead of 11. And then the other thing I do want to point out is that on May 31st, there will not be any class. That is Memorial Day. And if we were face-to-face, we wouldn't be meeting. And so in this world, we're also not going to be meeting. So on that Monday, you can enjoy the day off. Hopefully it's great weather. You can go hike a mountain, go sit on the beach, do whatever. But anyway. All right, so there's the schedule. All right, one more thing I want to talk about real quick is I just want to show you how to access things on Canvas because some of you might be new to Canvas. So this is what it should look like when you're in our classroom or in our class shell, Canvas shell. So the course information module, that just has all of the links to things that are kind of useful. This first one brings you to this Zoom classroom. The second one brings you to my student hours, my office hours. This brings up the syllabus. And then if you want to go to the textbook, this link will take you there. So I just put that all up on top so you've got it handy. And then you'll see we've got chapters 7, 8, 9, and they're all broken down by sections, right? So you can always click on things like if you want to read from 8.1, there are little video lessons from time to time and all that. Okay, so then in terms of assignments, probably the easiest way to get there is just to click on assignments, and it will bring you a list of all the different assignments. Notice that the due dates are all on them, so you can see exactly like the 7.1 practice. That one's due April 12th, next Monday at 11:59 p.m. Our first quiz is April 14th. All right, there you go. Starts at 11, ends at 11:40. Anyway, so you can always click on these, and when you click on them, they will bring you to My Open Math, and you got your problems to do, right? And so you can do them in any order. You can just jump down, or you want to try, right? Something else. And the beautiful thing about these is that you can actually see right away if you get something correct or not. All right, so I'm just going to put in a couple of answers here. So you'll notice that on this part, I got a green check mark. This one, I got a red X. This tells me that I got the first one right. The second one is incorrect. And so I only got part of the points, 4.75 out of 10. I don't know why it didn't give me 5 out of 10 for being half right, but probably some weird rounding thing. But the really good news is you can always try another one. There you go. Well, let's get a similar question here. And this will allow you to change your score. So let's get this one right. And we'll get this one wrong. Uh-oh, why did that give me wrong? All right, so this actually was a really good illustration. This number, by the way, minus 3736. Oh, no, it's not right. Should have been over 18. Anyway. Yeah, there you go. Okay, so I got that one right now, minus 37/18. And you notice how it also gives you this little key thing where it says key. That lets you actually see what the correct answer is. But you can always retry these, and if you finally get them correct, you'll get full credit. You can take them multiple times, and in fact, you can see over here where it says like 997, 998. Right? I can keep doing this 997 times, basically an infinite number of times. All right, so this is going to be where you get your practice, where you do your stuff. All right. So that's if you want to check your grade, you can go to grades. It will be blank, or it should be blank because you haven't tried anything. But you'll see your scores out of whatever's going on. It also gives you an overall grade. So really good resources to know exactly where you are and how things are going. All right. Well, I think I've done enough with that. So let me stop sharing here. We'll pop back. So I've been talking for like 40 minutes. And I threw a bunch of information at you, but I'm just curious, are there any questions at this point? Does it all seem pretty standard? All right.
I think we're pretty good.
Okay, and then and that just reminded me. Thank you, Benjamin, for chiming in because I forget you asked me earlier about attendance policy. Attendance policy, I have none. I have none whatsoever. You can come to class. You cannot come to class. It's totally on you. You guys are adults. You're here for whatever reasons. I'm gonna get paid regardless as long as I'm teaching class. So if there are only 2 of you, the 2 of you will spend 2 hours with me talking trig. So you can come or not come, but it's totally on you to make sure that if you don't come, you're getting the information that you need. But I've got the videos up, I've got student hours and that sort of thing. So in terms of attendance, come or don't come, it's totally on you. I don't care. And that's probably weird, huh? To hear a teacher be like, yeah, I don't care if you come to class, but I don't. I'm not your dad. Right? You've got your own reasons for doing your things. And if you've got better things to do than come to trig class, trust me, I understand, right? Okay, so we're all good? All right. Well, then I think what I'm going to do is I'm going to hop up to the whiteboard. Now, you may have noticed that there's another little screen here that has my name on it, but also shows a whiteboard. I actually have a physical whiteboard behind me. I don't know if you can actually see it because of the glare. If I change the lighting a little bit, you can maybe see. But I'm going to hop up there, switch to the other screen, and start teaching you some trig. We'll start talking about what this stuff is all about. All right. So I'm going to hop up there. I'll be right back with you. Slight technical difficulties. Hold on a second. Okay, I think we're good. Sorry about that. All right, so trigonometry. What the heck is trigonometry? Well, let's just actually start with the name. Let's break it down. I'll tell you something about mathematicians. If you don't already know this, mathematicians are kind of boring. You already know this. So mathematicians are kind of boring, and especially in the way that we name things. We name things exactly what they are. So check out this trigonometry. Let's break it down. All right, so first we got tri. That means three, right? Like triplane is a plane with 3 wings. Tricycle, it's a bike with 3 wheels. All right, so tri is 3. Metry. This comes from meter, which means to measure. So if you've ever got something that ends with meter or metry, means measure. So a good example is like geometry. Geo is earth, so geometry literally means measuring the. Okay, so we got something about threes. And so what about gone? What does that make you think? You ever heard that suffix before? You can throw something in the chat window. Say something if you got to get like, where have you heard gone before? G-O-N.
When like talking about geometric shapes like hexagon and like octagon, that's what comes to mind.
Cool, thanks, Danielle. Yeah, that's where most people have heard this, like exactly hexagon, pentagon, and you think geometric shapes, right? So like a hexagon is a 6-sided figure. A pentagon is a 5-sided figure, right? Well, it turns out that gone doesn't actually mean sides. It means something else. We'll talk about that in a second. But a trigon, you put this all together. So this is a 3-sided figure. Okay, well, a 3-sided figure, that's better known as a triangle. So trigonometry literally means triangle measurement. So that's all this class is. It's triangle measurement. How hard can that be? We're just going to measure triangles. Easy. And yet we have an entire quarter on it, an entire class on it. Well, you'll see that trigonometry is deep. I mean, it started as exactly this. We're going to measure triangles. But it led itself to all kinds of other stuff. All right, so that's all trigonometry is. We're going to measure triangles. Easy. No problem. So let's talk about that. If we have a triangle, how do we actually measure it? So here's a triangle. Now I want to measure it. Well, let's kind of think about the different things we might measure. What might you measure in a triangle?
The sides.
All right, sides, like the lengths of them. All right, so maybe we want to measure, say, the lengths of sides. Well, that's going to be pretty easy. Give me a ruler. I can measure those, no problem. All right, what else might you measure?
The area of the triangle.
Okay, cool. The area, how much space is there in it? Right, like if this is a field, what's our acreage? If this is a window, how much light is coming through? All right, so maybe it's area. Cool. What else could you measure? Other ideas?
The
Angle.
degrees of the angles.
All right, cool. Angles. Right, what about measuring the angles? Again, easy enough if you've got the right device, like a protractor or something like that. Well, these are really the three things that the classic trigonometry was about, was finding the lengths of sides, the sizes of the angles, and the area within them. Now, we will talk about all of this in this class. Obviously, it's triangle measurement, so we will hit all of these. But I want to start with angles, because angles are kind of a weird thing. And they are super important for us when we go further in this trig idea, just some of the things that angles entail. All right, so we're going to talk a bit about angles. So we'll start geometrically. I don't know what your geometry background is, because I don't know any of you. So I don't know what you've seen with your geometry, but an angle is defined by two rays that join together at their endpoints. All right, so this is an angle. It's got two rays and the point where they come together. The point where they come together has a name, it's called the vertex. So it's two rays that come out from a vertex. So this is technically what we mean when we talk about an angle, which I guess means in a triangle, we don't technically have angles. Well, now I know some of you just went, no, wait, what? We got angles. They're right there. 1, 2, 3. Okay, but remember I said technically we don't, because we don't have rays. We just have line segments. So even though by definition there have to be rays, we allow ourselves to call them angles, even if those are just line segments, if they get cut off. So instead of it being a ray, if it just ended at a point here, we're still going to talk about this as an angle. All right, but technically it's two rays. All right, so the question then is, what are we actually measuring when we measure an angle? What does that mean? Because if we've got rays, those rays go on forever. So those lengths are infinite. I guess we could talk about where a point is, where that point is, but that doesn't really matter, because I could take those rays and that vertex and I could turn it and move it somewhere else, and it's really the same angle. And so really what we're doing with an angle, this is how I like to think about it, is that measuring an angle means that we're measuring rotation. So I'm going to put here that the measure of an angle is the measure of rotation from one ray to the other. If you don't like the idea of a ray, it's that from one line segment to the other. But basically it's a question of, suppose that this set of pens is my one ray. How far do I have to rotate until I'm at the other ray? Okay. So angles is going to do you a lot of good if you think of angles as rotation. How far do we rotate one side of this triangle to be on the adjacent side? Right? So if I start here, I rotate up. How much of a rotation did I do? That's what angles are actually measured. The bigger the rotation, the bigger the angle. right? The further we have to rotate, the larger the angle value. All right, so this is what we're really doing. We're going to be measuring how far we have to rotate from one ray to the other. Okay, cool. At least now we're all on the same page of what does it mean to measure an angle. Now, to do this, we're going to be nice and systematic, and we're going to start with what we call standard position. So this is another thing about mathematicians, another one that you probably know. Not only are we boring, but we're also really systematic. We're really technical. We're really nitpicky on details. We have very specific ways we want things done, right? Okay, well, same thing here. When we talk about angles, there is a standard position. There is a way that we form this always, so that no matter who you are, no matter where you are, we can all look at that angle and agree that it's in standard position. Okay, this is the way it starts. All right, so here's what standard position means. All right, first of all, let's draw the coordinate axes here. You guys are used to, right? With the good old X and Y. So standard position means that one of the rays is on the positive x-axis. And the vertex is at the origin. The other ray is going to be, again, coming out of the origin. And the rotation is going to occur in a counterclockwise direction. Okay, so this is what it means for standard position. Vertex is at the origin. So at the crosshairs, where the crosshairs meet. So the vertex is the origin. The rotation is counterclockwise. For you British, anti-clockwise. The rotation is counterclockwise. And the initial side is on the positive x-axis. All right, so we call this one down here the initial side. And why it's the initial side is that's where the rotation starts. We started with our ray on the x-axis, and then we started rotating. So that means this other ray, this other side, is what we call the terminal side. So every angle has an initial side and a terminal side. Start at the initial, go to the terminal. And for it to be in standard position, the initial side needs to be on the positive x-axis with the vertex at the origin. So we're always going to set things up this way. When we talk about angles, we're always going to go back to this picture. We're going to go to standard position when we talk about them. Okay, so that's a little bit about the geography of an angle, just the names and everything. But the other thing that you should know is that when we name angles, when we want to be generic and give them a name, we use letters for their names, but we use Greek letters, kind of as an homage to the ancient Greeks, because they were the first ones to actually study geometry and trigonometry. So you know how, like in algebra, when there's a number you don't know, we just put in an X or a Y or a Z, right? We put in a variable. Same thing happens here with angles. We just name them with Greek letters. so let me introduce you just to some Greek letters that you're going to see that we use for the names of angles. So I want you to think of these things just like you think of X, Y, Z, W, variable letters. They're really the same thing. All right, so the first one that you'll see a lot is this guy. The circle, a horizontal line through it. This is the Greek letter theta. Theta tends to be probably the one we go to the most often. Think of it like X, right? You use X as your kind of standard variable. Theta is the standard angle. Okay, but it's not the only one. You'll see a lot of them. There's another one that's a circle with a vertical line through it. And this is the Greek letter phi. So PH makes that sound like photo, right? Phone. So that's PH, so phi. Some people also call it phi. Right? So both of those are interchangeable, phi or phi, but never faux or fum. That's a really, really bad one. So I'm a dad. I got kids. They're grown up now, 26 and 19. But I'm like the king of dad jokes. So phi, phi, faux, fum. I smell the blood of an Englishman.
I totally got it. That's really funny.
Okay. I appreciate that you got it, but don't lie. It wasn't funny. It wasn't funny. No. All right. Okay. So theta and phi, those are kind of the ones you'll see the most often. But a couple others that you'll see a lot. This guy that looks like a little fish. This is alpha. That's actually the first Greek letter. Another one that you'll see looks like a little curvy B. I draw mine with the tail. This is beta. It's the second Greek letter. And then a third one, we'll run into this later a lot. Kind of looks like a fish that's swimming downward, like a really narrow fish. This is gamma. Okay. So these are the primary ones you're going to see. I want to get them out here so that when I start writing them, you know what I'm talking about. So when all of a sudden I draw one of those, you go, well, what the hell is that? These are just Greek letters. All right. So theta and phi are kind of your generic, kind of like how we use X and Y. And then alpha, beta, gamma, those are the first three letters in the Greek alphabet. So we use those kind of like A, B, and C. All right. Oh, fun fact while we're here. I like to also teach you guys things that are not really related to math also. But check this out. So the Greek alphabet starts with alpha, then beta, then gamma. So check this out. We start with alpha, and then you go to beta. I don't know if you see where I'm going with this. Drop that A. Alphabet. If you've ever wondered where that word came from, now you see it. You know how we learn our ABCs? Well, in Greek, you learn your alphabetas. You learn your alphabet. Mind blown. All right. Anyway, for those of you who are going into the sciences, which probably most of you are, most people don't take calculus or pre-calculus for the hell of it. You're going to do it to take calculus because then you're going to go into sciences. You will learn all the Greek letters. Like by the time you're done, you'll be able to have. But anyway, there you go. All right. So what we're going to see a lot when I draw an angle and I go to standard position, I'm just going to write here by this little arrow. Little curvy arrow. All right, the angle. So this is the angle theta, so that later when we reference it, we all know what we're talking about. Okay, so there's our standard position. Now, there are some other things that we should know about regarding the angle in standard position that we're going to use to describe angles later. So let's go ahead and talk about a few of those. First thing is, can you have a negative angle? And probably your initial reaction is no, right? If it's a, if we're looking in a triangle, we just look at the rotation from one side to the other. If it's a measure of rotation, how can you have negative? Well, we actually can have negative angles if we're in standard position. Negative just means we're going to go the opposite direction. Something else I don't know if you've caught, but like negative numbers, the only difference between negative numbers and positive numbers is which way you go. Think about it on a real number line. Positive 5, 5 steps that way. Negative 5, 5 steps this way. Only difference, which way we're going. So the same thing is true about negative angles. Can you have them? Yep, you can. These just rotate clockwise. So the only difference between a positive and a negative is which way we rotate. All right. So let me draw a negative angle for you in the standard position. So standard position, we need our initial side to be on the positive x-axis. So that's right here. And if I wanted a negative angle, I would just rotate this way. All right, so there is a negative angle. So positive angles, negative angles, they're both equally valid. It's just a matter of which way we're going. Okay, so we're good with negatives. Negatives can happen. Another thing that we're going to talk about are what we call coterminal angles. All right, so again, come back to mathematician think, right? Think like a math person. This name tells you everything. All right, so coterminal. What does the prefix co mean? What's that make you think?
Like together or shared.
Okay, together, shared, common, right? Like when we cooperate, we operate together, we work together, right? So co means shared. So coterminal, these are angles that have the same terminal side. So it's possible to have two different angles that are yet coterminal, whose terminal sides are actually in the same place. They're pretty easy to show. Let me, again, create standard position here. Let's go with, I'm going to make a green angle here. So there's my initial side, and let's say its terminal side is over there. So we'll call this guy, say, theta. I could also, though, let me make a blue one, where I rotate the other way. So these two angles are not the same. The green is a positive. Oh, let me give this a name. Let's call it, say, alpha. So theta is a positive angle because it's rotating counterclockwise. Alpha is a negative angle because it's going clockwise. And yet their terminal sides are exactly the same place. So we call these coterminal. It can also happen even if they're not one positive, one negative. You can actually have two positive angles that are also coterminal, like this. All right, so here's going to be my first angle. I'll make this one in red. So I have to say that this is our angle theta. But I'm going to draw another one. Let me go in kind of a teal. And what it's going to do is it's going to rotate around a full circle and then a little bit more. So if you look at this like teal spiral, you see it goes all the way around and a little bit more. So these are different angles. I know when I get to this, sometimes people are like, oh, I don't see that there's any difference here. Let me show you. Let me show you the difference. So this is going to be my side that I'm rotating, right? So I'm going to start with it here in the initial position of the positive x-axis. So here is theta, the red one. I just rotate and I stop. Okay, so I go through this kind of rotation. The teal one, this is what I do. I rotate all the way around in a full circle, and then I go a little bit further. Okay, so now you can see that the rotation is not the same. It took longer for that second angle to come all the way around. So these are still coterminal. The terminal sides are still in the same place, but they have different measurements. One of them was much longer. So if we think about it as rotation, we should start being okay with the fact that if you do more spins, it's a different angle. Great example. Great example. Think snowboarding. Think about the Olympics. Think about when someone's on a half pipe and they're doing their tricks. Right? And they come up to the top and they, spin around a little bit. If they just go spin around one time, oh, boring. You don't get random points. I don't care about that. You spin around 3 times. Whoa, that was pretty crazy. Right? So we even know in real examples that the number of rotations definitely matters. Right? There's a big difference between a 720 and a 1080. And if I'm speaking language you don't understand, that's okay. I'm just trying to throw out an example of where rotations, the number of rotations matter. So there are a lot of instances where we need to know the number of rotations. And so we'll do that here as well. We'll keep track of that by just drawing circles for every rotation. We'll just make that spiral bigger to account for how many times we rotate. Okay. So like in this example with the teal, you can see the one full rotation and a little bit more. If I wanted 2 rotations and a bit, I would have gone around once, gone around a second time, and then a little bit more. Right. So we can actually keep track of that. Since angles are about rotation, extra, complete revolutions matter. And so we'll hold on to that. All right, so coterminal. Share a terminal side. Doesn't matter how you get there. Whether you go positive, negative, do extra loops, and it doesn't matter. It just means that they share the same terminal side. All right, so that's what coterminal means. And then another thing that's going to be really important to us is knowing where that terminal side is. So I want to remind you about something. I say remind because you probably have seen it in pre-calc. If you haven't, don't panic. Don't panic because it's pretty easy to pick up. But when we talk about the coordinate plane, we got our X and our Y. Those axes actually split the coordinate plane into 4 pieces, right? I mean, you can see them. There are these 4 chunks. So we call these quadrants, right? So the axes, they split the plane into 4 quadrants. So just think quad, 4s, that's the quadrants, the 4 chunks. And what we do is we number them. We specify which quadrant they are by number. All right, and so this one up here where X and Y are both positive, we call that quadrant 1. And we're going to use Roman numerals for this one. All right, so that's quadrant 1. So the other ones are quadrants 2, 3, and 4. And we actually name them in this order. So quadrant 2 is the upper left. Quadrant 3 is the lower left. And then quadrant 4 is the lower right. Okay, so I bet a lot of you have seen this. If you haven't, again, this is just how we number them. And it may feel weird, and you may not have ever thought about this, but when you were first taught this, you might have gone, well, why are they numbered this way? Why is it quadrants 1 and then 2, 3, and 4? Well, I think you can tell now. If you think about angles in a standard position, suppose we start with our initial side in the positive x, and we just start rotating in a positive direction. What's the first quadrant that we run into? Quadrant 1. That's why it's called the first quadrant. We keep rotating, and now we're in the second quadrant. Then we get to the third, and then we get to the fourth. Okay, again, math teachers are so obvious in how they name things. If I'm going to be in standard position, what's the first quadrant that I run into? Well, that's the first quadrant. All right, so that's why they go quadrant 1, 2, 3, and 4. So later, after we start defining the trig functions, we're going to be really concerned with which quadrant is the terminal side located. Is it located in quadrant 1, 2, 3, or 4? Because it's going to tell us something. All right. So just recognize that this is going to matter. We're going to actually care when we look at an angle what quadrants it's in. So like if you look at the two that I have here, where I was showing you coterminal. So on this first picture, theta and alpha, those are both what we call quadrant 2 angles, because their terminal sides are in the second quadrant. This one, I guess I didn't name the second one, but both the red and the teal, those are both first quadrant angles, because their terminal side is in the first quadrant. So notice we're only concerned with the terminal side, not the initial side, because the initial side is always on the positive x-axis. So it's only where the terminal side is, how we classify it in terms of which quadrant we're in. Okay, so you can have quadrant 1 angles, quadrant 3 angles, fourth quadrant angles, and so on. So then probably the next question, if you're kind of watching what's happening here, might be, well, what happens if our angle, say its terminal side, isn't in a quadrant? Like, let's just take this one where there's our initial side, and let's say we rotate until we're such that our terminal side is on another axis. Okay, so look at this one right here. Is it a first quadrant angle? Is it a second quadrant angle? Well, the terminal side isn't in the first quadrant. So it's not a first quadrant angle. The terminal side isn't in the second quadrant. So it's not a quadrant 2 angle. Okay, well, we still want to be able to name these, right? Like we still want to be able to say what it is and how we name them. And so we actually call those quadrantal angles. And so a quadrantal angle, this is just one where the terminal side is on one of the axes. It's either on the x-axis or the y-axis. So when we rotate from standard position, if we end on one of the axes, it's called quadrantal. Okay, so since a lot of it's going to matter where that terminal side is, we also need to know about these ones that aren't in a quadrant, so we call those quadrants. All right, so we got all these definitions, all these terms telling us about angles, but I don't know if you've noticed this. I haven't talked about measuring them at all yet, right? We haven't actually talked about, well, what kind of numbers do we use to measure them and what do those mean? I've just told you that we're going to use rotation. So we should probably define some scales for measuring angles. I already know, you guys know about this first one, right? But let's just get it out there. In terms of units of measurement, we use two primary ones. All right, the first, what we call degrees. This is the one that you guys know pretty well. The other one that we use are what we call radians. So this is kind of like, think about this. Suppose I were to ask you to measure the length of something. So like measure the width of my whiteboard. So you crack out a ruler. I could give you that answer in lots of different numbers. I could give it to you in inches. I can give it to you in feet. Give it to you in meters. I could give it to you in centimeters. I could give it to you in furlongs. Be a really small number. I could give it to you in light years. It's an even smaller number, right? Like we have lots of different units for measurement. Okay, it's the same thing with angles. We can actually measure them in many different ways, but they're kind of the two standards, degrees and radians. You can kind of think of it as our standard system and metric, right? I can measure this in feet or I can do it in meters. All right, well, so degrees and radians, kind of the same deal. All right, now, in terms of degrees, I think you guys already know this. When we're talking about rotation, remember angles are measured in rotation. What do you know about degrees and rotation? Because I know you guys have heard this. What do you guys think of when you think of degrees and rotation? Spinning around in a circle.
A full rotation is 360 degrees.
Beauty. Yep, that's what most of us know. In terms of degrees, the way that it's set up is that one rotation is 360 degrees. And we use that little circle for the degree symbol. But one rotation is 360 degrees. And that's the kind of thing, like, remember I was talking about the snowboarding in the Olympics. When they say somebody hit a 1080, they're saying 1080 degrees, which would be 3 full rotations, right? Or 720 is 2 rotations and so on. So that's how we define it. Just one rotation is 360 degrees. So if you do a partial rotation, you get part of 360 degrees. You get whatever portion of the rotation that you did, right? So come back to like this example, this angle. Remember this one that was quadrantal? When I rotate from the positive x to the positive y, I've gone 1/4 of the way around, right? 1/4 of a full rotation. So if I take 360 degrees and I divide it by 4, that tells me that this is a 90-degree angle. You know better as a right angle. But right angles, those are the ones that are in corners, right? Like the corner of the whiteboard here. It's a 90-degree angle. The corner of this eraser is a 90-degree angle. We're used to 90-degree angles. Right? Those are right angles, but it's 90 degrees because it's 1/4 of the rotation. So what if I rotated halfway around? So instead of just going a quarter turn, I'm going to rotate halfway. Well, take your 360 divided by 2. That's 180 degrees. So 180 degrees just means now you're going in the opposite direction. Well, we actually use that in our everyday language, right? right? And think about when we talk about somebody pulled a 180, means they just like completely changed their opinion. They're going the opposite direction. It turned around, right? So 180 degrees would be halfway around. Well, we could kind of continue this idea. What if I rotated so that I'm now in the negative y direction? Well, that's 3/4 of the way around. So that would be 270 degrees. And then if I were to continue rotating, let's say I just rotate all the way around in one circle. So I end up here. This would be 360 degrees because I've done one rotation. All right, so that's all the quadrantal angles. Obviously, if I rotated a different amount, I'd be somewhere else. So for example, how about this? Where is 135 degrees? Let's see if we can figure out where that would be. All right, so use the quadrantal angles as sort of your guideposts. 135, that's going to be more than 90, but less than 180. So I know that's actually going to be in quadrant 2. Well, let's see. If I do 90 degrees, I've got another 45 degrees to go. Well, 45 degrees is going to be halfway through one of these things. So 135 degrees would be this angle right here. So that's how we can negotiate where we are by given an angle number. We can figure out what quadrant we should be in. And then go the appropriate extra amount. So some big numbers that you're going to see, 45s are big because 45s are half of these chunks. But other good numbers are 30s. You have angles that are multiples of 30 degrees. We like those. And the same thing with 60 degrees. There turns out to be lots of really good angles for measuring rotation because 360 has lots of divisors. You can divide evenly into 360 by lots of things, right? You can divide it by 1 evenly, by 1, 2, 3, 4, 5, 6, not 7, 8, 9, 10, not 11, 12. So think about that, just from 1 to 12, 10 of those divide evenly into 360. It's a really nice number. And that's probably one of the reasons why 360 is the number of degrees in a rotation. I say one of, first of all, we don't actually know. We don't know for sure where 360 comes from. But it does have lots of nice divisors, which is probably why it ended up being 360. Most likely, it's based on the number of days in a year. Think about the number of days in a year. It's 365. If you think of this as like a rotation, that's a pattern that was observed by lots of people, lots of peoples through the years. The fact that it takes 365 days for that cycle to continue. But they probably opted for 360 instead of 365 just because easier. So anyway, but there you go. So there's degrees, 360 degrees in one rotation. Now, like I said, this is the one that you're probably really familiar with, which is cool. That's awesome. If you're not familiar with it, that's all right. Like you'll get comfortable with it. But at least most of us have some sort of an idea of one of the scales for measuring angles. But here's the bad news. Degrees, ugh, they suck. They suck mathematically. In calculus, if you were to deal with all of angle stuff in degrees, it's way more difficult. Through the roof more difficult. Radians are far superior mathematically. Okay, but here's the problem. Most of you have no clue what radians are. It's a meaningless number, like, I don't know about radians. So I'm going to have to try to get you up to speed on radians because radians are super important. They're crazy useful. Okay, well, then what are radians? Bruce, if you say that it's more important and better, maybe you should teach us. Yeah, let's talk about radians. Where do they come from and what do they mean? All right, now radians are a little bit weird in terms of the definition, but I'm going to argue that the definition makes a lot more sense than one rotation is 360 degrees. All right, so here's the deal with the radians. Radians are defined in this way. Okay, so 1 radian is the rotation needed to make the arc length of the circle equal to the radius of the circle. I'll give you a second to write that down. All right, okay, so 1 radian. It's the rotation that you need to make it so that the arc length of the circular arc is equal to the radius of the circle. Yeah, I know. At this point, you're like, can we just go back to 1 rotation is 360 degrees? Oh, no, we can't. But let me just show you. I think you see a picture, it makes a little more sense. So let's say that we're in standard position. And I'm going to start with just a line segment here that I'm rotating. Okay. So instead of a ray, I'm just going to look at a line segment. Now, if I start rotating this line segment, I want you to think about the point that's on the far side here on the end. Suppose that I've got my pen on here and it's attached to a piece of string. And I start rotating. The shape that I'm going to see, the shape that I'm going to draw out is a circle. Just squint, pretend that that's a circle. Right? But if I were just to be out here and just rotate, I'm going to draw a circle. All right. So the way that we're going to define a radian is how far do I rotate until the arc length. So the arc length is going to be this. So that length is the same as the radius of my circle. Because there is going to be a point at which, there's going to be a time in which that does end up being the same. Right? So if we call this length R, that length is R as well. So if that happens, this guy theta is 1 radian. So if you go 2 radians, you've swept through that your arc length is now twice the radius. 3 radians, now it's 3 times the radius, and so on. So what we're calculating with radians is multiples of the radius length. And that's how it gets its name. When you think about radian, radial, radius, right? But they're all related. So it's called radians because 1 radian is such that the path traveled along that circle is equal to the radius of the circle. And here's what's kind of cool. It doesn't actually matter how big the circle is. You change this radius, you make it small, you make it really big. The same rotation will get you the same relationship with the arc length. But the arc length is still going to be the size of the radius. So it scales up. It's kind of cool. Right. So this is what radians mean. They're totally just related to how far to rotate. Okay, so yay, that's a radian. So maybe what would be a really good question is, how many radians are in one rotation? If I go all the way around in a circle, do one complete cycle, how many radians did I do? Well, let's see if we can figure that out, because remember what the radian is, it's the number of multiples of r. So suppose I were to do the full circle here like I drew with the blue. So if I were to rotate all the way around, right? So I do this full circle. What arc length do I have? That's also known as the circumference of a circle. So how about this? Do you know the formula for the circumference of a circle? You want to remember that one?
Is it
okay.
like pi r squared? Pi r?
So there's pi, there's r's in it. Yeah, so pi r squared is the area, but the circumference is 2 pi r. Oh, and by the way, if I ask a question like that, like, do you remember? It's totally fine if the answer is no. Totally fine. Remember earlier I said I don't judge you for, not knowing something mathematically. Same thing here. If I bring up something and I say, hey, do you guys remember this? It's probably better if you guys are honest with me and go, nope, don't, so I can backtrack and tell you. So it's totally cool. Throw in the chat box. No. If you're showing your video, shake your head. Right? Whatever. It's totally fine for you to go, no, I don't remember. All right. So I prefer just honesty. Because again, no points, no credit, no judgment. All right. Well, anyway, so the circumference is 2 pi r. So remember what radians are. They're a measure of how many radii did we go around. Well, that means what are we multiplying to our radius? Well, it's 2 pi. So if we're in radians, degrees are such that one rotation is 360 degrees. With radians, one rotation equals 2 pi. 2 pi radians. All right, so again, I know that you look at that and go, 2 pi, what kind of crazy number is that? Well, it's not a crazy number, it's how many radii are on a full circle. There are 2 pi. So this is now where let me bring in my math guy. The math guy in me sees this and is like, oh my God, that's beautiful. Don't judge me. Right now, I see it. It's beautiful because it comes from just this, okay, we're going to define it in terms of arc length. The 2 pi makes total sense because I know that circumference formula. I've used it before. I understand how it works. So now that we're saying a full rotation is 2 pi of them, well, sure, because it's 2 pi radii. It's coming from somewhere real. This 360 was arbitrary. I don't think you realize that. They could have pulled any number out of a hat. How many degrees in a rotation? 387,406. Why that number? I don't know. Why not? And I know you're probably going, no, but the 360 makes it. 360 was just randomly chosen. And you're comfortable with it because you've used it a lot. But it's out of nowhere. Like if we were going to try to use math to talk to aliens, I'm sure you've seen this in the movies where it's like, ooh, that's how we communicate with aliens is through primes. And I'm not convinced that would actually work. But if we were to do that, if we tried to describe rotations using degrees, they wouldn't have any remote chance of figuring out what that means. if we get the idea of pi across to them, which is potential with circles, and we talk about radians, they're gonna eventually figure out what that means. They're gonna see that connection because it's coming from somewhere mathematical. So my goal with this class, by the way, not today's class, but just trig, is that by June, you guys are comfortable with radians. It may not like make sense. You may not see the beauty in it like I see it, but at least you're going to be able to use them. All right. So I'm going to start weaning you off of degrees. At the beginning, we'll do lots of stuff with degrees, but as time goes on, we'll do fewer and fewer degrees and more radians, because that's the stuff that actually matters later. All right. Well, now that we've got this, now that we know that one rotation is 2 pi, we can kind of do the same thing where we can do partial rotations and all that. So let me just show you how the quadrantals work in terms of how many radians they are. While I'm drawing this up, I also want to point out that when we do radians, we don't put a little symbol up here, right? Like degrees, you have the degree symbol. Radians, there is no symbol. We call them dimensionless numbers. They're just 2 pi. So it's going to be really important that if you put a degree symbol, that means degrees. If you don't, it means radian. All right, well, check it out. Here are our different angles for the quadrantals. If we rotate up here to the positive y, now we've done 1/4 of a rotation. So if you take 2 pi and you divide it by 4, that's an angle of pi over 2. So 90-degree angle is the same as pi over 2 radian angle. If we were to go halfway, well, half of 2 pi is pi. So when you see a radian angle of an angle of pi radians, it's the same as 180 degrees. So it's halfway around the circle. If we go 3/4 of the way, so we come down here, this is now 3 pi over 2. And if we do the full circle, as we saw, this guy is 2 pi. So probably the easiest way to think about these, forget about the pi, think about the number in front of it. But notice that I'm counting by halves. 1/2, 2 halves, 3 halves, 4 halves. Each time I do go through one quadrant, I just added half a pi. So that's just how this goes. So those are our quadrantal values. So if you have something else, some other number, you can kind of do the same thing that we did before, which is look at where is that in relative to these numbers. It will put you in the right quadrant, and you can go from there. All right, well, here's the conversion that you're going to want to use. If you're ever looking at degrees and radians and you want to convert, you're going to use the fraction that has 180 over pi. Come back to this circle, or this picture I was showing you. Remember that half rotation was pi radians. In degrees, that was 180 degrees. And so there's the fraction that holds that conversion. Hopefully you're good with that. Whenever you convert, you always just use a fraction that's got the conversion of the two. So when we want to convert, we're just going to take this 180 over pi, and we're going to multiply by that or the reverse, right? So if you want to go from degrees to radians, you're going to multiply by pi over 180. If you want to go from radians to degrees, you're going to multiply by 180 over pi. So it's just a matter of getting it lined up properly. But that's all you have to do if you want to convert from one to the other. So let me show you with a couple of examples. And then I'll talk about how I remember which one to use, which way I line it up. So for example, let's say we have minus 300 degrees. All right, so minus, that just tells us we're going around clockwise now instead of counterclockwise. We're going to go 300 degrees. So that's going to bring our terminal side somewhere up in here. Because I go negative 90, negative 180, negative 270, and then a little bit more, negative 300. But let's convert that to radians. So what I'm going to do is I'm going to multiply by pi over 180. Right, because I'm going from degrees to radians, so I multiply by pi over 180. Now, what we're going to do is we're going to leave this as a fraction of pi. We're not going to actually go to the calculator and get a decimal. We're going to leave it as a fraction of pi. So let's think about 300 over 180. If you were to reduce that, drop off the 0, so it's 30 over 18. You can divide those both by 6. And so this would be minus 5/3 pi. Minus 5 pi over 3. And that's how we're going to want to write it. When you're doing the homework on the My Open Math stuff, it's going to say write it as a reduced fraction of pi. Sometimes it'll have the box where you type something in and then the pi outside of it, because they're already saying the pi is there. So you just put, like in this case, the minus 5. But we're going to tend to leave them as fractions of pi. And you'll understand why in a little bit. Once we play around a little bit more with angles, especially what we call the special angles, you'll see why having them as a fraction of pi can be useful, because it will tell you a lot about where it is and what it looks like and describe it. All right, so there you go. We went from degrees to radians. Minus 300 degrees is the same as minus 5/3 pi. All right, well, how about this? Let's do, say, 2 pi over 5. And let's change that to degrees. Well, since I'm going from radians to degrees, I'm going to multiply by 180 over pi. All right, now, here's the other nice thing. If our radians are in fractions of pi, when we convert to degrees, those pi's are going to cancel. Yeah, that's all right. I don't mind that. So now I'm just going to take 2 times 180 and then divide by 5. And I'm pretty sure that that's 72. So 2 pi over 5, that's equivalent to 72 degrees. All right, so that's how we can do the conversion. But as promised, I want to show you how I remember which one to use, because it can be a little confusing, right? You go, I don't really remember. Well, here's how I like to think about it. Let's say I'm starting with degrees. I need to get rid of degrees. And the way that I can get rid of degrees is by dividing by degrees. So you notice how in this conversion, my degrees are on the bottom. So I get degrees on top, degrees on bottom. They're going to cancel. Same thing when I'm going from radians to degrees. I need to get rid of the radians. So I want the radian bit on the bottom. So I've got radians over radians. Leaves me degrees. Or alternatively, you can think of it as what you want goes on top. If I want to end in degrees, I go with degrees on top. If I want to end with radians, I put radians on top. That's kind of an easy way to remember which way to put it into play. Okay, so there's converting between degrees and radians. But regardless, these are the units that we're going to use to measure things. There are some others that are out there. They're really fringe. I don't know really anybody that tends to use them anymore. So we're going to concentrate just on degrees and radians. And like I said, I'm going to start working on getting you away from degrees. We'll start pushing radians. Okay, well, I see by my clock that we're pretty much out of time here. So just so you know what to expect on Wednesday, we're going to pick up where we left off. We're still in the middle of the first section. We're slightly behind schedule, definitely not enough that we need to worry about. But I want to talk a little bit more about some of the things that we've seen here, some more definitions. And then I'm going to show you how we actually use this with triangles. We'll get to the triangle measurement bit, at least with right triangles. And I'll introduce you to the trig functions. There are 6 of them. So I'll introduce them to you, and then we'll start playing with them. All right, so that's the goal for what's going to happen on Wednesday. In terms of homework and all that, obviously the first homework set's not due till Monday. However, you can probably go and do most of 7.1. I would say probably 90% of that work we've already talked about. So I highly recommend you get in there, start playing around a little bit with it. Maybe dust the cobwebs off the brain if it's been a while, or at least start getting the practice. So get in there, start working on 7.1. But other than that, I'm going to wish you all a very happy couple of days, and I will see everybody on Wednesday.
Thank you.
Have a good one.